Right, so this is going to be a 25-minute talk with hopefully some time for answers. I'm going to get cracking. Really excited to be here. This is the second most nervous I've ever been doing a speech here. Almost exactly 12 months ago today, I did my wedding speech in this room. So I'm really a lot calmer and more settled today than I was 12 months ago. And what a wonderful space to have the first cloud-focused conference in Perth. My name is Haak. I'm an AWS solution architect. My job is probably what I think is the best job in the world. I get to play with all of the fancy toys that AWS come up with, and I get to work with a lot of our customers in helping them build really, really cool stuff using cloud technology. And the best bit about my presentation, I think, when we're talking about deep learning, is that my background is as a developer, not as a data scientist, not as some sort of academic that understands deep learning. So I'm really trying to throw a developer lens on deep learning, and I really want to, if you walk away with one thing in your head today, I want it to be that deep learning is highly democratized. It is very, very accessible for developers today, and you don't need a PhD, you don't need a degree to go and build some really, really cool stuff. So I'm going to quickly cover what we think deep learning is, what's changed recently to make it popular. There's a bit of resurgence, why you should focus on it as a developer, where to focus on it, and also where to get started. So, machine learning is an old topic. It's been around for a long time, and even the concepts for deep learning have been around for a long time. I'm not going to focus on reinforcement learning today, but check it out, it's pretty cool. You can see that reinforcement learning is winning at some of the AI StarCraft competitions and a lot of the sort of gaming style things. Supervised and unsupervised learning is where both traditional artificial intelligence as well as now deep learning comes to play. And the general theme here is that deep learning is taking every bit of traditional machine learning and generally getting better results. So when I say why focus on AI, if you look at this graph, on the right, this outlier is this year's registration for NIPS, which is a huge, kind of the premier AI conference globally in Paris. And it sold out 40 days before it started. And on the left graph, we have this straight line is Stack Overflow questions for Django. And every single other one of them is a Python-based framework that has something to do with artificial intelligence. So there's a lot of hype in the market, and there's a lot of craziness, and venture capitalists are investing in everything that says AI, and it just sometimes seems like it could be a little bit of bullshit. So, you know, is it really something that is worth focusing on? So, probably 10 years ago, the maths and the real case for deep learning was proven out. But what has been changing very rapidly is the convergence of abilities to store stupidly large amounts of data, the ability to spin up stupidly large amounts of computing power to run some of these algorithms that are ridiculously expensive, from a 10-year-old perspective, but at the hands of any developer with $30 on their credit card today. And so we're finding that convergence means that problems that normal AI would be trying to solve, deep learning is getting much, much better at. And this is another reason why developers should pay attention to AI. This is an internal graph that we have about one of our services that does image recognition. And this is our internal payoff graph for how valuable is more engineering effort versus just throwing more data at the problem to train a better algorithm. And you can see there's a certain point where it actually matters way more about the amounts of data that you get in than the engineering effort that you throw in. So it's kind of a bit sad in some ways that, elegant engineering can give you some diminishing returns compared to just crunching out more data sets. And I think this is also really important for deep learning, and this is around this concept of feature engineering or feature extracting. If you have a big mine site with systems pumping out tons and tons of data about what's rolling between different systems, or an oil and gas plant, or a complicated system with whether it's a game or any kind of complicated system pumping out lots of data, it can be hard to tell what pieces of that data are significant in order to indicate the outcome that you're looking for. Deep learning is very good at just taking a huge set of data and working out the features within it that are important to give you the answer that you're looking for. So here, obviously, if you're looking to differentiate between an apple and an orange, you are going to struggle if you're going with circular shape, but deep learning is very good at going, okay, well maybe in this particular case, colour is going to be a very strong differentiator. So it's great at working that out for you, which takes out a lot of effort that a data scientist would normally have to work out for themselves. So I think there are a lot of use cases in Perth and in Western Australia, in the market that we work in, where these types of technologies can start to augment and fix a huge amount of problems that are in these businesses. So I think geospatial data and the ability to go and throw subsurface models, the ability to go and look at data, even if it's aerial photography for agriculture, and be able to tell if disease is around on a very micro level, is very compelling. Behaviour analysis, Amazon, our retail site, has a swathe of behaviours analysis and that sort of stuff on the purchasing site that we work on. But I think there's a huge amount of industrial use cases that are really relevant to developers in WA particularly. So what do you actually need to learn? Let's start at a high level and just say you don't actually need to know anything about deep learning at all. You don't even need to know convolutional neural network. It just doesn't really even matter. And that's where you can start consuming commoditized deep learning via an API. Now, all of my examples are pretty much Amazon services. They're the ones I know. I have trouble keeping up with just the stuff that my own company puts out. I'm not trying to pretend that there aren't a whole bunch of other really good ones out there, but I am highlighting just using AWS ones because they're ones that I can actually speak to with authenticity. So some of the services that we offer as an API where you don't actually have to worry about the tech behind it are Lex, Poly, and Recognition. Has anyone seen, I'm sure everyone knows what an Echo is, or a Google Home, a device that you can just talk to, it doesn't have a screen. So the technology behind these is pretty complicated in the way that it handles natural language understanding, and we've released that as a service called Amazon Lex. So what Lex does is you can think of the information that you need if someone's asking you in a question. You can parameterize that information. So think about booking a flight, or booking a meeting, or something that has a couple of variable inputs. The number of ways that you can ask that in English, or in any other language for that matter, is pretty incredible. So the whole point of Lex is that you sort of declare the kind of information and the kind of questions you're expecting to be asked, and the natural language understanding and the word recognition behind it parameterizes that and starts calling your functions so that you can actually get an outcome rather than doing AI to understand words. So think about, a hotel booking is a good example here. You can, you choose your slots, and you might say, I want to book a flight, and to New York. You might not say where you want to book a flight to, and it'll have to ask you, and the permutations can become pretty intense. And then you can also go in and switch your conversation flow. It's like, would you like to book a hotel with that as well? Or, would you like someone to come and pick you up when you land? That sort of thing. So the next thing I wanted to talk about was AWS recognition. So this is another service that we have. Has everyone heard of ImageNet? ImageNet is this annual competition that is run to detect objects within an image. It's an academic competition. Deep learning algorithms started winning it about 10 years ago, and today they absolutely dominate even a human's ability to look at a picture and correctly label what you can see in the picture. So this is another example of something that so many academics have been working on, have released algorithms to go in and do that. There's not always a great reason for you to be able to go out and build it yourself. So this is an example of a service that is providing a highly commoditized piece of AI that can go and do face detection, it can go in and do object detection, and if anyone's got a QR code scanner, I was going to do a demo, but sort of laptops in a different spot. You can take a little selfie or take a photo of something, and this is just a static JSON web app sitting in an S3 bucket that will let you upload a photo. We don't store the photo, but it'll just run some analysis over it and tell you what's in it. And so, for example, if you throw a face at it, it'll tell you if it's happy. If you call the compare faces API, you can kind of tell within a degree of certainty if two faces are similar or not. You can also go and try and find a face within a group. So, is Fred in this group of people? Because I have a sort of fingerprint of what Fred's face looks like. Similarly, you can go and throw a scene at it and it'll tell what's in there. And this is a very strong analogy to what this ImageNet competition does. There's a lot of academic information on how to build this yourself, but there's not actually a lot of value in doing so because it is commoditized. So there are just a couple of examples of if you want to consume AI as as an API and not worry about the AI underneath it. What if you actually want to go a little bit deeper into some deep learning? And this is where we start walking down on this sort of cake. So everyone knows, hopefully within this room, so that's a bit of an assumption, FizzBuzz, a bit of Python code. It's sort of a bit of a standardized developer interview question. And I think developers have a lingua franca. We can usually look at a bit of code, be confused for much longer than we would like to admit, but then eventually understand what it means. When you start looking at deep learning, you start looking at this kind of stuff and just go, this is a whole new language. It's very, very, it's actually quite confronting as a developer to go and look at something that's sort of like code, but you have no idea how it works. And for another example, so this is a bit of glue-on code. This is a new framework that Amazon and Microsoft together have released that is a very flexible way of declaring AI algorithms. So this is a glue-on definition of a network, and this is what it is visualized. So, this is an architecture diagram for deep learning, and it can be quite confronting, and I personally really try to study and understand the maths, but the reality is you don't actually need to understand the maths of this in order to get a good result. And here's an example of a customer that we have. They actually just got acquired. They were a deep learning focused video recognition company, and they built a product that can scan video live and recognize brands that are in that video. So they're selling this to, the company is called Gemsoft with a J. They've been sold, so they don't exist anymore really. But this technology they released you can now go on and write that as a fast recurrent convolutional neural network in TensorFlow or MXNet or Keras or any of the deep learning libraries. And the industry is moving so quickly that while this was cutting edge a year ago, you can actually go and write 100 lines of Python and do something very, very similar with video processing and brand recognition. And similarly, this is a lot of the technology behind how driverless cars operate. This is an example of a segmentation problem where the algorithm's job is to separate the road from everything else. So you can see the road is just sort of highlighted in green there. When I'm moving from an example that you can probably code in overnight through to something that is, really quite a complicated system, but this is the kind of stuff that also gives, the big guys like Netflix agility. Netflix were able to launch in 30 countries and 30 languages independently and simultaneously, because all of their recommendation engines abstracted away the actual language and abstracted away a whole bunch of stuff that is globalized. So very interesting in terms of helping businesses move fast in this use case. And I think there's also some really interesting use cases sort of underground. If you think about a lot of industrial systems, both oil and gas and mining, there are places where you don't get connectivity and you don't get a lot of intelligence about where you are, and you have very you have systems that are not connected all the time, and you can start to think about running deep learning stuff on those devices where they're not dependent on a network. So where should you focus your efforts? When you look at the sort of cycle of deep learning and AI, it's very similar to a standard CI/CD style iteration cycle, right? There's a feedback loop. You build a model instead of code a lot of the time, but usually that model is wrapped with code, and that data needs feedback, and it's some sort of cycle. So I guess when I say where to focus your effort, I'm not being prescriptive, but I'm just saying what parts of this problem can you actually go out and outsource to another system or platform, and what parts are actually important that you differentiate on. And I'm just going to sort of wind up with some ways of running inference in production and some architectures that I'm seeing customers actually use at the moment. So we have customers building and training on EC2, but they export a model, and when they're trying to run the inference and the actual the AI part of that execution, they're running it on Lambda. We've got a lot of customers who are A/B testing their models, so you don't know if a new algorithm is better or worse than the last one, so you need to actually have infrastructure that can give feedback on the performance, kind of like a canary in a sort of continuous deployment model to work out if your AI is performing. And you need, and Amazon itself actually has a repository of reusable models. So I've built a model that predicts X from a picture. Go and put that in a repository like you would a NuGet repository. That's maintained by an owner, but you can actually go and pull that model out and run inference on it without having to build it in the first place. For training, cloud is very sensible, especially with per second or per minute billing, where you can get your result on a huge amount of GPU clusters 10 times faster by running 10 times as much compute, and you don't necessarily have to pay for it. And I think another really emergent pattern is running inference on the edge. So inference on the edge is, it's very expensive computationally to build AI models, and you're probably going to need a lot of GPU, and probably if a cloud platform is a good place to do that. But you can go and invoke your inference on lots and lots of different things. Your phones that understand you saying, "Okay, Google," or "Hey Siri," or Cortana or Alexa, they're all running a LSTM neural network on your device, very low power, just to understand you saying that one word that wakes it up to then go and feed the rest of the data into a more heavy strength algorithm. So that inference on the edge thing is really interesting, I think. And that's really, you've got to separate your data analytics, your training, and your prediction. And the prediction is where that's the edge use case. So if you dive a little bit further into the data science side of things, please don't take too much from this. This is where your ML and AI platform starts to look just like a standard data lake, and a really, you need to do your data cleansing. It's the same as any kind of data science, garbage in, garbage out. And is that video going to work? Yeah, so this is a good example of inference being run on the edge. This is an NVIDIA piece of compute that has quite a lot of GPU on board, and they're able to run the object detection on the drone itself. And I think there's a really interesting use case for shark detection in this kind of thing in an Aussie market. But that's a really interesting example of a model that's trained on cloud but deployed on an edge. If you want to go and run some distributed training yourself, AWS has some quick starts. They have a CloudFormation template that will spin up the amount of compute that you need on demand so that you can run a cluster, and then you destroy it when you're done. Just wanted to make a quick point about AI technical debt. If you treat your AI output as just set and forget, you are going to have a bad time. This was a problem Tesla had with their autopilot. The first time the vehicles saw salt lines on the road, they got very confused about where they were on the road. And this is an example where you just need more data to train the algorithm to understand the nuances of how to behave. And the other thing is, when you start going into industrial systems where the AI is controlling actual sensors and effectors, you are controlling, you're actually changing the system. So you need to have a system that has a feedback loop that is able to adapt continuously to the changes that it's enacting in the first place. Okay, I'll finish off with where to get started. And firstly, it's kind of worth picking an area, because the API high-level stuff won't be a lot of effort for you to start learning. But you're probably going to want to go and look around the platforms and frameworks area. And my strongest recommendation is to check out the fast.ai course. It's I think, the best deep learning online course that you can do, and I would combine that with something where you don't have to install GPU drivers and install all the frameworks. Go and pick something that's already set up, whether it's a Docker image or whether it's an Amazon machine image or whatever. Don't go and install all this stuff and spend days actually trying to get up and running. This stuff is already done. There's going to be lots more services coming out that makes sort of installing AI frameworks pretty irrelevant in the future. Amazon has AI as a part of a lot of its DNA, and it's been really exciting to be a part of looking a little under the hood and seeing what goes on there. And the final thing I would say is, don't try to boil the ocean. Go and pick some tiny little problems. Go and pick up like one function of your app that could be enhanced by AI, and try and see if you can get a better result out of that, rather than trying to write a driverless car framework, because that actually is hard. Thank you very much.